Hello all. Let us learn something about I2C and DAC. DAC is nothing but digital to analog converter and I2C is I square IC or inter-integrated communication. So I2C or inter-IC communication, which was originally invented by Philips. So up till now, till the curriculum that we have completed, what we have learned is we have learned a communication standard called as RS-232. This RS-232 communication standard, or you can say RS-232 communication protocol, has or it can communicate one to one, and it can transmit one bit at a time. Whereas I2C, which is also called as bidirectional bus and it uses bidirectional bus to communicate. So it can communicate uh, over multiple devices using just two wires. So these wires are called as SDA and SCL. Now, which devices can participate into this communication? So all the devices which have this SDA and SCL line can participate in this communication. But let us see what is an I2C or how it I2C what it is. So I2C is stands for inter integrated circuit. It is also pronounced as I squared C or I2C or IIC. Two wires that the bus consists of are SDA. SDA stands for serial data and SCL stands for serial clock. If you see below diagram, you can see device 1, device 2, device 3, device 4. So all these four devices are participating in the I2C communication. So any device can communicate with any other device. In this communication standard, there is a master and a slave. So every device which has this SDA and SCL line can participate. So data is transmitted over SDA line and clock is generated by the master on SCL line. Let us go into much details. So these are the two lines. So if you see, this is SDA and this is SCL, and there are various devices. So devices can be A to D converter, D to A converter, it can be LCD, RTC. RTC stands for real time clock. Microcontrollers can also be part of devices. So whichever device will initiate the communication is called as master, the others are slaves. Now at a time there are multiple devices which can communicate with each other. Now 8051 for example cannot participate in this communication standard. The reason being is it does not have SDA and SCL line. Now, but its family member 89V51RD2 can communicate, because if you see pinout of 89V51, you can find two lines SDA and SCL. Two pins are there. So whichever IC has these two pins can participate in this communication. So LCD also you will have to select in that way, A to D or D to A also. So all the chips are different which participate in this communication standard. So in our practical lab, what we are going to do is we are going to practically generate an analog signal. So D to A converter using, so we are going to communicate 8051 with D to A or DAC via I2C. Let us go ahead now. So before starting with the communication, whoever initiates the start pulse is the master. That was what I said on SDA line. So let us see what is start and stop condition in I2C. So if you see, these are the two lines SDA and SCL. So during one clock pulse, when the SDA line is pulled low, who will pull this SDA line low? If you see, these are the four devices. Whichever device out of these 4 5 devices will pull this SDA line low. So SDA line is initially high, and any one of these devices will pull this SDA line low. So whichever device will pull this SDA line low, that will act as master, and the other are acting as slave. So if this microcontroller pulls this SDA line which is high and it pulls it as low, in that case, microcontroller is acting as master and the others are acting as slaves. Similarly, to stop the communication, the master will pull SDA line high, and then after some time it will pull SCA line high. So this will tell all the devices which are participating that communication between two devices is complete. So let us consider that microcontroller is communicating with, say, ADC or DAC. So what will microcontroller first do is microcontroller will first pull SDA line low. Then every device participating in this communication will understand that microcontroller wishes to communicate with any one of us. So with whom, that is not known by microcontroller, that is not known by any other devices. So every device is eager to know with whom is microcontroller going to communicate with. So microcontroller, what he will do is send a start pulse. All devices come to know that he wishes to communicate. Now let us look at this timing diagram. So when microcontroller pulls this SDA line low, for every clock pulse, SDA line will have some data. Now let us see what data it will have. So initially when it is pulled low, now all devices are have understood that microcontroller wishes to communicate. Now with whom microcontroller wishes to communicate, that is not known. So what will microcontroller do is microcontroller will send address of the device with whom microcontroller wishes to communicate. That address will be 7-bit address, and it will also be followed by whether he wants to read or write. So if I wish to write, I will send high, and if I wish to read, I will send low. So depending upon whatever you want to do, the data will be sent. Then so look at this diagram now. So SDA line, what start pulse will go, then the 7-bit address will go. So every device is peeping into this SDA line, checking whether the address is of it's or not. So D2A converter now understood that it is his address. So rest all devices will keep quiet now, and D2A converter will start communicating with ADC. Sorry, microcontroller. So D2A converter will acknowledge microcontroller by pulling this, keeping this line low, SDA line low for 1 clock pulse. So SDA line is low, so that would be acknowledgement from D2A converter. Next, microcontroller will send data. So for every clock pulse, so for 7 clock pulses, each bit data is sent. Again when data is received, again the slave, which is DAC, will acknowledge that it has received data by again sending a low. In this way microcontroller will continuously keep on communicating. So he will send data, then slave will acknowledge by saying it has received, then he will send data again. So this is how the communication between microcontroller and D2A converter will keep on happening. Finally, when microcontroller finishes sending data, he will send a stop pulse or stop condition, and all the devices will understand that communication is over. Now any other device again can initiate communication by pulling SDA line low. So this is how microcontroller or any other device can communicate with each other using I2C. So when one communication is over, the next communication can start. So this is it for today. So listen to the video, and thank you for patiently listening. Thank you again.